Hello! I want to show you a demo in this video. Here is the plan. We will build a simple self-propagating virus that prints Hello World using the virus software framework that comes with this course. We'll look at different parts of the framework as we learn various infection techniques down the road. The framework makes researching virus so much easier because it has bundled up all the building blocks for you. By the end of this course, you will be able to reproduce this demo completely on your own. After our toy virus that prints Hello World is compiled, we will infect an arbitrary binary on our system. Let's infect the pwd program that prints the current working directory. Then, we will run the infected executable and see it silently infect other executables in the same directory. By analogy, after the patient 0 was first infected with the virus, it will organically spread to other patients in the vicinity. I have prepared the virus for you already, and let's take a quick look at the code. We will introduce the virus framework and the files in the repository later in the course and show you how to set things up. The file we're looking at is called self-propagating virus. It contains a main function, and the structure looks pretty much like a normal program. We first define a string literal hello world, and then perform a write system call that prints the string onto the screen. Then, we invoke this function that replicates all the code here in this main function and infects executables we can find in the current directory, including child directories 2 levels deep. It basically means that our virus will print Hello World and then search for other executables. As soon as another executable is infected, it will do the same thing, print Hello World, and infect others. I'm going to run some commands to build this virus and an infector program that allows us to infect our patient 0. If this looks alien to you, don't worry about it. I will explain what these commands are later in the course. First, let's compile the virus, and then let's infect our pwd program. After this command is run, we have made a copy of the original pwd program into the temp directory and infected it with our toy virus. This infected copy is named as victim. Let's see if it still works. The victim binary first prints out Hello World, which means our virus has been executed. Then it prints out the current working directory, and this is what it's supposed to do. We have successfully infected a copy of the pwd program without changing its original intended function. Let's copy over some other common programs on the system and see how the virus from patient 0 spreads silently. Let's copy the ls CPU program that prints out CPU information. Then, let's run our patient 0 that is highly infectious. Let's run our copy of the ls CPU program again. It now prints Hello World before printing CPU information. Our patient 0 carrying the toy virus has silently infected another binary in the same directory. This is pretty cool, but I want to show you something even better. Our virus framework that comes with this course has tools that allow us to experiment different infection algorithms on a large amount of executables. Instead of providing a specific executable to infect, we can pass a directory to it, telling it to infect all binaries inside of it. Again, I'm skipping a lot of details about the algorithms we use here, since we'll discuss them later in the course. What you see here is a giant table of infection results. The first column is the name of the executable, the second column is the type, and the last column is the infection result. The infection rate is pretty high, as we only failed for 12 out of 570 binaries. We will cover many different infection algorithms, and each of them comes with different trade-offs that might give you different results here. Let's see what VirusTotal says about our infectious patient 0. It looks like none of the available antivirus engine marks it as malicious. If you write something like this for Windows that attaches arbitrary code to executables, which recursively tampers with other executables, I'm sure many will complain loudly. Linux antivirus is such an underinvested market, but it's a very legit target. I know this demo just makes everything look so easy. It is not, even for seasoned software engineers. We will cover all the pieces that are crucial to the inner workings of a virus and reveal a software engineering process that is somewhat unconventional. By the end of this course, you will have in-depth knowledge on how a virus is built, as well as the ability to craft your own self-propagating code. I hope this gets you motivated, and I will see you later.